Welcome back. So, today we're taking a classic first year college economics concept and, well, making it actually useful in the real world. We're diving into how we make choices using a framework called indifference curve analysis. Okay, let's get right into it. Instead of getting bogged down in abstract math, we're going to look at this through a totally relatable lens. Think about your favorite foods, your weekly budget, and how you actually figure out what makes you the absolute happiest.
I want you to picture yourself right in the middle of a grocery store aisle. You've got a limited budget in your pocket and you're staring down your two absolute favorite foods. Are you going to fill your cart with more slices of pizza or are you going to load up on more tacos? It's the classic dilemma, right? Every single time we shop, we're making these constant trade-offs to maximize our own personal satisfaction. And believe it or not, economists actually have a very specific visual way of mapping out this exact grocery store dilemma.
According to our source material by Bubu Sensawa, this whole concept is formally known as indifference curve analysis. It's basically a geometrical approach to analyzing consumer behavior, propounded by economists Hicks and Allen. Now, the source notes that this measures utility ordinally. Let's translate that academic jargon, shall we? All ordinal utility means is that you're just ranking your food happiness. You don't have to say, a slice of pizza gives me exactly 10 units of joy. You just have to know whether you prefer a certain combination of pizza and tacos over another, or if you rank them exactly the same.
Consider this indifference schedule we have here, which is really just an economist's fancy term for a list of different shopping baskets. Let's say good X is pizza and good Y is tacos. In basket L, at the top, you get one slice of pizza and a massive 18 tacos. But jumping all the way down to basket R, you get 6 slices of pizza but only 3 tacos. The absolute core rule here is that to this specific shopper, every single one of these baskets yields the exact same level of total satisfaction. Whether you pick basket L, basket N, or basket R, your overall happiness remains totally unchanged. Because you're equally happy with any of these combos, you are completely indifferent to which one you end up with. Make sense?
And this brilliantly illustrates how we take that exact shopping schedule we just looked at and turn it into a visual map. Just look at the curve labeled I1. Every single point on this continuous line, L, M, N, P, Q, R, represents one of those grocery baskets. By plotting pizza on the bottom horizontal axis and tacos on the vertical axis, we've created a literal continuous map of equal happiness. Literally any point you choose along this specific line is a winning combo for your satisfaction.
But wait, how do we actually move from one basket to another? Well, this introduces a concept called the marginal rate of substitution, or MRS. Think of MRS as the ultimate grocery aisle trading game. It measures the exact amount of good Y, our tacos, that you are willing to sacrifice to put just one additional unit of good X, our pizza, into your cart, all while keeping your overall happiness perfectly level. It's basically the live exchange rate happening right there in your brain.
Now, this internal exchange rate drastically changes depending on what's already sitting in your cart. In the first trade, early on, to get to combination M, you were willing to forgo 5 whole tacos just to get 1 extra slice of pizza. I mean, the ratio is 5-to-1. But contrast that with the second trade scenario. By the time you get down to combination Q, your cart is already full of pizza. Now, to get just 1 more slice, you're only willing to give up a single taco. The exchange rate has absolutely plummeted down to 1-to-1.
This shifting dynamic is what economists call the principle of diminishing marginal rate of substitution. Think about it. When you only have 1 slice of pizza, you are desperate for another one, so you'll happily trade away a bunch of your abundant tacos. But as your cart fills up with pizza slices, your remaining tacos become incredibly precious to you. You're going to guard them much more fiercely. Therefore, you are willing to give away less and less of them.
So the really crucial point here is that your changing psychology in the grocery aisle is what directly creates the shape of this curve. The marginal rate of substitution isn't just some abstract number. It is quite literally the declining slope of the curve. Notice how steep the curve is at the top left when you're willing to trade 5 tacos for a pizza slice. And then notice how flat it gets at the bottom right when you're only willing to trade 1 for 1. Your declining willingness to trade makes the slope literally flatten out.
Okay, let's see how this builds when we introduce more money into the equation. What if you just want more happiness overall? Well, in an indifference map, we don't just have one curve, we actually have a whole family of them. If you shift to a higher curve on the map, moving out to the right from I1 to I2 and then to I3, your level of satisfaction goes up. Why is that? Because shifting to the right means you're reaching a point where your cart is significantly fuller, containing more of both items. More pizza and more tacos equals a higher level of satisfaction. It's a win-win.
before we look at the specific rules these curves follow, we really have to understand the foundational assumptions of rational shopping that make this whole theory work. First, the consumer acts rationally to maximize satisfaction. Second, choices are consistent. And third, and this is a really big one, is transitivity. This basically means that if you prefer basket A to basket B, and you prefer basket B to basket C, then logically you absolutely must prefer A to C, right? If pizza beats tacos and tacos beat burgers, then transitivity says pizza absolutely must beat burgers. It's just what keeps our economic models logical.
With those assumptions in mind, let's break down the core properties of these curves. First up, an indifference curve has a negative or downward slope, which honestly is pure common sense when you think about it. If you want to stay on the exact same level of satisfaction and you toss more pizza into your cart, you have absolutely no choice but to put some tacos back on the shelf. If you gained pizza without giving up tacos, your total satisfaction would go up and you just jump to a higher curve. So to stay on the exact same curve, the slope has to be negative.
Now, what if two indifference curves intersect, like the crossing lines we see here? Well, our source tells us this is actually impossible. Why? Because it completely breaks that transitivity rule we just talked about. The point where they cross would represent two different levels of total satisfaction at the exact same time, which, yeah, makes zero sense. Instead, indifference curves must be convex, meaning they bow inward toward the origin, as you can see mapped out next to it. And remember why? It's exactly because of that changing willingness to trade we discussed earlier, the diminishing marginal rate of substitution.
Finally, notice how the indifference curve cannot touch either the x or the y-axis. It just kind of hovers right above the lines. If the curve actually hit the axis at point M or point L, it would mean the consumer is spending all their resources on just one item and walking out with absolutely zero of the other. But a core assumption of this specific analysis is that the consumer is comparing and consuming a combination of two goods. Come on, you've got to have at least a tiny bit of pizza to go with your tacos.
So look at that. We've completely transformed a rigid economic theory into a real-world shopping trip. We've seen exactly how our internal exchange rate dictates our choices, why the curves slope downward, and why more is always better when shifting right on the map. I want to leave you with a final thought today. The next time you find yourself staring down two of your absolute favorite items in the grocery aisle, actively weighing which trade-off brings you the most joy, ask yourself, what exactly does your personal indifference curve look like today? Thank you so much for joining me on this explainer. Keep asking those great questions, and I'll catch you next time.